We're back. We're going to talk about limits. This is your next unit. Probably spend a couple weeks on this and then have a big test at the end of it. It'll be your first test. So limits are y values. That's why I'm spelling it weird. I understand how to spell limits, but that we're going to put the y's there to kind of hopefully help you remember that limits are y values. So what limits are? It's the y value that is being approached as the x value approaches a given number. So the y value that is being approached as the x value approaches a given number. Whether or not the y value exists at that x value makes no difference. All I care about is what it looks like the y value is going to be. It might not actually be that at that spot, but that doesn't matter. We want to know where the roads are headed. I don't care what happens when I actually get there. I care what it looks like the roads are headed. So there's a few ways you got to be able to do these. The first way would be on a table. But this might kind of hammer home the point of what we're trying to do here too. So, I drew these before, so if you wrote up these charts before, so if you want to pause it and draw these, and then restart it, listen to the explanation, that might be good. What we're looking at here is I got this table, and this is some equation. I don't know what it is. It doesn't matter. And I want to know, as x gets closer and closer to 3, what does it look like the y value is doing? Again, remember that f of x and y are the same idea. So as x gets closer and closer to 3, what is the y value doing? Well, as I come toward 3 from the left, you can see as I get closer, these numbers are getting bigger, but it looks like they're going to level off at 10, just based on this being 9.99, and then from this side, it's 10.01. So as I come from this side, the y values are going up toward 10. As I come from this side, they're going down toward 10. I don't know what happens when x equals 3. I don't care what happens when x equals 3. It looks to me as though the y value should be 10, or it's heading towards 10. So therefore, that's your limit. All right, the same idea applies here, except there's an extra thing I threw in here. So for the limit to exist, it must be the same from both sides. This might be a little tricky to tell on a table. I think it's easier to tell on a graph. But let's look at it and see what we can come up with. So as x approaches -1, well, if I look at going, these numbers are a little bit to the left on a number line. So they're actually smaller than -1. They're a little bit to the left of -1. So if I'm somewhere to the left of -1 and I start coming toward -1 from that side, these y values are getting bigger, and they're heading toward what looks to be like a y value of 4. The problem is, or what's different here, is as I come from this side, so this is also heading toward an x value of -1, but these y values are heading toward a y value of -4. So up here, we had a match. It looked like it was coming to 10 over here. It looked like it was coming to 10 over here, so the answer is 10. This one looks like it's going to 4, looks like it's going to -4. So what we say there is the limit does not exist. So if the limit exists, it's going to be the same from both sides. All right. If it's not the same from both sides, you say it doesn't exist. So if I look at what that might look like in a graph, just kind of making up this graph here. Let's say we got these x values, those y values, and let's say this is h of x. That's just the name of the equation. So if I asked you to find the limit of, as x approaches 0, of h of x, What we're looking for is as the x value gets closer to 0 from each side, what does the y value look like it's going to do? So as I approach 0 from this side, we're going there. As I approach 0 from this side, we're going there. And from both sides, the y value that's being pointed towards is a y value of 0. And so therefore, that's your limit. And in this case, the graph also goes through that point, so it's actually an actual point in your graph, which means something down the road, but for right now, it's not really relevant whether there's a point there or not. We just want to know where it looks like it's headed. Let's say I asked you for the limit as x approaches 2 of h of x. So we got a different situation here. So as x approaches 2, well, if I come to 2, an x value of 2 from the left-hand side, I'm on this road over here. And that is pointing towards a y value of 1. But if I come towards x equals 2, I'm following the road from this side. It's pointing toward a y value of what I'll call 3. I'm not sure how level that is. But what that means, if someone said to you, hey, what's the limit as x approaches 2, you've got 2 answers. And 2 answers doesn't get it. So you got to say that it doesn't exist because it's heading towards there from one side and there from the other side, and the roads just don't come together. That limit does not exist. Now, if I asked you for the limit as x approaches 2 from the left, so this no negative sign means we're going to come at x equals 2, but we're going to come at it from the negative direction, so from the left. So I'm going to find x equals 2, I'm going to jump just to the left of x equals 2, so I'm over here, jump on the road and start seeing where my y value looks like it's headed, and that answer is 1. That's just a one-directional limit. It's called a one-sided limit. One-sided limits don't have to match up because there's nothing to match up with. There's just one number. So when I come to it from the left, the y value is 1. If I came to it from the right, so as x approaches 2 from the right-hand side, well, now I find x equals 2, I jump over to the right of it a little bit, find my road, and drive back towards x equals 2. That looks like it's heading toward a y value of 3. And again, that's a one-sided limit. It does not have to match up with anything, and you can give me a number. So from the left, we're headed toward 1. From the right, we're headed toward 3. But if I ask you in general, hey, what's the limit as x approaches 2 overall, you got to tell me it does not exist because we got 2 different things there. All right, let's say I asked you for the limit as x approaches 3. And this is where I'm talking about it doesn't matter whether the y value exists at that point or not. So x equals 3 is here, and if I jump to the left of x equals 3 and get on the road, it's heading toward that y value. If I jump just to the right of 3 and head down the road, it's heading toward that y value. There's not a y value there, but that doesn't make a difference. It wouldn't matter if I put a closed dot up there. What it looks like the roads are heading toward is a y value of, I guess, 4 based on how I drew this graph. I don't care if this point is there. I don't care if it's there. I don't care if it doesn't exist. The roads are headed towards a y value of 4, so that limit would be 4. All right, we'll do a few more of those. I'm going to run over and turn the lights off. It might be easier for you guys to see. So let's make another, just kind of making up graphs here. So let's say this is 1, 2, 3, 4. This is a height of 1, 2. Let's just work with this for a little bit. Let's say this is g of x. That's the name of the function. So I could ask you a bunch of different stuff here. I could ask you to find, let's start here, the limit as x approaches 0 of g of x. So as x approaches 0, that means I got to find 0 and drive towards it from both sides. If I drive toward it from this side, if I drive toward it from this side, I'm heading toward the same y value. That y value is 2. So because it's the same from both directions, that's going to be your limit. We want the y value as long as it's the same from each side. At x equals 1, we got a different set of circumstances here. So let's go through all three. If I ask you the limit as x approaches 1 from the left, as x approaches 1 from the negative direction, so I find 1 and I go just to the left of it, and then I start driving down that road back towards x equals 1. The y value that it is heading towards is a y value of 1. There's not a value there, but that doesn't matter. It looks like that's where the y value is going to be. So that is your limit. If I asked you for the limit as x approaches 1 from the right, so from the positive direction, find x equals 1, go just to the right of it, jump on the road, and start driving back towards x equals 1. And the y value we're heading towards is a y value of 0. If I asked you for the limit as x approaches 1 in general, you've got to look and see if it's the same from both sides. And if it is, that's your answer. And if it's not, then your answer does not exist. So we just did it, but I can see here that at x equals 1, at this spot here, the roads don't meet. They don't come together. So from this side, I'm up here. From this side, I'm down here. So that has to be, does not exist. All right, let's say the limit as x approaches 2. So I'm not asking you right and left, but you still have to think about it. So even if you're not asked, it's still, you got to consider the right and the left every single time you do these problems. So x equals 2 is here. So if I jump to the left, start driving down that road, it looks like it's heading toward a y value of 1. If I jump to the right of 2 and start driving backwards down that road, it looks like it's heading toward a y value of 1. That means your limit is 1. I know that's not where the dot is. I don't care. The dot could be here. The dot could be right in that circle. The dot could be not exist. Doesn't make a difference. We don't care about the dot when we're looking at limits. The roads are heading toward there. That's our limit. Limit as x approaches 4. From the left of g of x. Now there's a little bit of a, I guess, disagreement. I don't know if that's the right word, but just different ways people will write this. And I've seen the AP test do both. Technically, for the limit to exist, it has to be a number. This y value is going up forever, so this is a vertical asymptote. So as I get closer and closer to 4, this is just going to get bigger and bigger and bigger. So technically, infinity is not a real number. So you can get away with saying does not exist here. Because it doesn't exist because there's not a real number that the road is heading toward a specific number. Also, you could say positive infinity. Because even though that's not like a technical answer where you're giving me the actual number that it's heading toward, since infinity is not a number, you're describing what's happening. And that's okay because that tells me you know what's going on. And I've seen those both ways. And Khan does it one way, the AP test does it kind of both ways. So we'll talk through both ways as we go. All right, let's look at one more of these. And if you feel like you got it, move forward. If you feel like you need more help, keep watching. If you want to kind of pause the video here and try this one and try to figure out some stuff before I put it on the paper, and that's cool too. Let's say we got this. Let's say this is 3, 2, 1, 1, 2, 3, 4, 5, 6, 7. So you should be able to find the limit at any one of those points, from one direction, from two directions, whichever. So I'm going to just kind of talk through a couple and I'll write down what I can and still fit it on the screen. Let's say I asked you for the limit. Let's name this first. This will be k of x. Limit as x approaches 0 from the right of k of x. I can only ask you from the right because it only exists to the right of x equals 0. So what I would do there is, go to the right of 0, jump on the road, head back towards an x value of 0, and it looks like my y value is tracking towards a y value of 3. So 3 is my answer. I don't care if there's not a dot there. I don't care if there is a dot there and it's somewhere else. It doesn't matter to me. The limit there is 3. If I asked you for the limit as x approaches 3, let's say, of k of x. Well, I'm not asking you about each side, but you still got to think about each side. So if I look at x equals 3 from the left, this is a vertical asymptote, so this is just going to get closer and closer and go lower and lower and lower and lower as we go. So from the left-hand side, we're heading towards a negative infinity. From the right-hand side, it's the opposite. This is going to get bigger and bigger and bigger as we get backtrack closer and closer. So from the right-hand side, we're going to a positive infinity. So you can actually say it does not exist here for 2 different reasons. One is that infinity and negative infinity aren't numbers. They're not real numbers. It's more of an idea, like this is as big as you can get. So the limit doesn't exist because we're heading towards infinity, but also the limit doesn't exist because it's different from each side. So the roads don't come together. So from this side we're going down forever, from this side we're going up forever. And so because those aren't the same, your limit doesn't exist. Let's say the limit as x approaches 4. Again, I'm not asking you about each side, but you got to think about it every time. So as I approach 4 from the left, so from the negative, I jump over to the left, I find the road, and I drive back towards x equals 4. I'm heading towards a y value of 2. If I go to the right of 4, find the road, and jump back, I'm heading towards a y value of 0. Well, those don't match. The roads do not meet. That automatically means does not exist. Let's say limit as x approaches 5. Again, I'm not telling you to look at both sides, but you got to always consider it. So as I approach 5 from the left-hand side, we're going towards a y value of 0. As I approach 5 from the right-hand side, we're going towards a y value of 0. I don't care if there's a dot there or not. From both sides, it looks like we're tracking towards a y value of 0. Therefore, that's your limit. Let's say limit as x approaches 1. So there's no dots there, but just to help you realize you can do this no matter what. So if I'm going towards 1, I'm going to go over here and drive towards x equals 1. I'll go over here and drive towards x equals 1. And if I do that, it looks to me like I'm tracking towards a y value of 2. In this case, there is a dot there. But again, with limits, I don't care. One more. Let's say limit as x approaches. As x approaches infinity. We'll do a whole lesson on that a little bit later, but we start to look at it now. So as x approaches infinity, so that x value is going all the way over here off the paper, way over off the screen. And as I go all the way to the right forever and ever, as I'm going that way, what is happening to the y value as I go is it's going up forever and ever. So yeah, we got kind of 2 options. Your limit here is technically does not exist because up forever is not a real number. Or you could say it's positive infinity because that does describe what is happening. Alright, sometimes these are much simpler than the ones we just went through. You don't see these very often on the AP test, but you could. Let's say y equals 2x squared minus 1, and I ask you for the limit as x approaches 3. Limits are just y values. So if you can plug into your equation and just get the actual y value, that's the easiest way. It's accurate. It's not going to come up very often because the AP test wants their questions to be harder. But if you can just plug in and get a y value, limits are y values, so that is your limit. So this would just be 2 times 3 squared minus 1. Remember your order of operations. 3 squared is 9. 2 times 9 would be 18. 18 minus 1 would be 17. So I'm not going to spend a ton of time on that because it doesn't come up very much. But it does happen. So if you get a situation like that, just plug it in. One more thing I would like to go through is sometimes you'll be asked to create your own graph. So I'll give you information and you'll have to make the graph. No, you know what? Actually, we're not ready for that because we haven't done horizontal asymptotes. So I'm going to stop there. Go ahead and try the 2 worksheets that are attached to this lesson and bring some questions for me tomorrow and we'll go through whatever you need to.